Hello, good afternoon students. Welcome to one more fabulous session from Infinity Learn. This is Suresh Avari, Faculty of Chemistry from Infinity Learn by Sri Chaitanya. Welcome to NEET Step Up 2025 program, a marathon sessions. Hi, good afternoon. How are you? Can you all able to hear me? Right. Very good. Hi. So many students are appearing. Hi. Say good afternoon loudly. Yes. Welcome to NEET 2025 Step Up program. In this Step Up program, my dear students, we are offering all sessions, all subject, physics, chemistry and biology, right from 12 o'clock afternoon till evening 6 o'clock. And we will be discussing those topics related to NEET 2025 syllabus and both 11th standard and 12th standard together. In a week from Monday to Saturday the sessions can happen, and first 3 days of a week 11th standard syllabus and the next 3 days of a week 12th standard syllabus. So in this first 3 days we completed hydrocarbons up to alkenes, then we are into the 12th standard, we are starting solutions. Yesterday we recaptured what happened in the previous session, and also we ended till concentration terms and solubility, Henry's law and couple of numericals, and stepped into the vapor pressure, right. So we will discuss some more details about the forthcoming topics. In today we are going to discuss about vapor pressure and Raoult law and other colligative properties. So in these sessions you please share these sessions and subscribe, and just first you like it, okay, right. As far as yesterday's class is concerned, do you have any doubts? Please let me know. Do you have any doubts? Please let me know. Yes, okay, that's good. Yes. Okay. So I am expecting some more students to come. Okay, let's see the topics that we have in this chapter: types of solutions, methods of expression concentrations, vapor pressure, Raoult law, colligative properties, abnormal molecular mass and Van 't Hoff factor. So in this journey we already completed types of solutions, methods of expression concentration, and here we completed solubility also and Henry's law also, and we are in vapor pressure. Ravindra Reddy, good afternoon. Hi. So when you come to the class now, you raise the Josh levels in the class. Good afternoon. Okay. So what is vapor pressure, and followed that we will be getting into the Raoult law. So let's see about the Raoult law here. So this is a vapor pressure. This liquid is converted into the vapor. This process is called evaporation. So when the vapor is condensing back to the liquid, that is called condensation, and in this evaporation and condensation there is an equilibrium, that is called state of equilibrium. In this equilibrium state, the molecules, vapor molecules are going to hit on the surface of the liquid, and they cause some force, and that force causes the vapor pressure. So the pressure caused by vapor molecules on the surface of the liquid is called vapor pressure. So this vapor pressure gives a lot importance in total colligative properties. We will go into the details of vapor pressure here. Vapor pressure of a liquid depends on two major categories. One is nature of liquid and the second one is temperature. So, let us talk about the nature of liquid. When the evaporation takes, the vapor, the liquid molecule should leave the surface of the liquid. So, I wanted to say here, if they have strong intermolecular forces, they do not leave the liquid surface. Therefore, they will be having less vapor pressure. I just want to say here, the nature of liquid means the liquid with low intermolecular force IMF, इंटरमोलिकुलर फोर्स, जो भी है इंटरमोलिकुलर फोर्स, वांडरवाल्स फोर्स हो सकता है, हाइड्रोजन बॉन्ड हो सकता है. So, the liquid with low intermolecular force will have high rate of evaporation, so that high vapor pressure. This is a simple method and a simple trick that you can understand, right? So, and the second one is temperature. We will be discussing about the Clausius-Clapeyron equation. So, you can see the vapor pressure of a liquid at a given temperature is independent on quantity. If you take this much liquid, if you take this much liquid, at that given temperature, the vapor pressure is same. So, it do not depend on the quantity, है ना? So, and the surface area also, maybe rate of evaporation increases with surface area, but not vapor pressure. And on the shape of the vessel also, I just want to say these are the independent. This point is very important, because in the NEET kind of examination a question can be asked. Okay. So, one more point, volatile liquids mean to say those liquids which has a tendency to evaporate are called volatile liquids. So, volatile liquids will have low intermolecular force, and non-volatile liquids. Can you tell me what are non-volatile liquids? Non-volatile liquids, they have high intermolecular force. If you take a petrol, it evaporate. It is an alkane, it evaporate. If you take a coconut oil, you keep in the vessel, it do not evaporate. How many days you leave it also, because it has more intermolecular force, right? Denoted by delta P, that is lowering of vapor pressure. Beta Ravindra Reddy, delta P, right? So, liquids having weaker intermolecular forces or attractions have higher vapor pressures. Such liquids are called volatile liquids. Example, ether, petrol, kind of thing. Acetaldehyde, diethyl ether, pentane are examples of volatile liquids. On the other hand, intermolecular forces are strong in metallic liquid like mercury. Vapor pressure of such liquids are always lower. You can take as a zero also. You can take coconut oil. You can take an example of glycerol. You can take an example of H2SO4 liquid, concentrated. H2SO4 concentrated looks like oil, so it is called as oil of vitriol. Suraj Rajput, hi. Why you are late? Suraj, late क्यों बेटा? So, सूरज सुनना बेटा, यहाँ पर हम डिस्कस कर रहे हैं वेपर प्रेशर का हिसाब से. So, liquids are two types. Those liquids has evaporating tendency, they can evaporate, they are called as volatile liquids. Those liquids do not evaporate because high intermolecular forces, they are called non-volatile solutes, so liquids. Volatile liquids ka ether, petrol, okay, acetaldehyde, diethyl ether, you can take it, right. So it's okay, don't say sorry. Sorry is not, okay. So sorry is a term for formality, but it disrupts the bonding, okay. Don't be casual, right. Talking about the non-volatile liquids, they have high intermolecular forces. Sulfuric acid, coconut oil and glycerol, these have great intermolecular forces, therefore they are not evaporating, they are non-volatile liquids you can consider, right. So vapor pressure and temperature, this is very important. अगले slide में आना है term, okay. So as you increase the temperature, vapor pressure increases, क्योंकि ये slide में देखो, ये पहला जो स्लाइड है, हाँ, अकॉर्डिंग टू काइनेटिक थ्योरी, काइनेटिक एनर्जी इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. अगर टेम्परेचर बढ़ेगा तो काइनेटिक एनर्जी भी बढ़ेगा. सो अगर काइनेटिक एनर्जी बढ़ेगा तो ये लिक्विड मॉलिक्यूल्स काइनेटिक एनर्जी बढ़ेगा, सो दैट दे हीट ऑन द surface of the liquid with more force, more kinetic energy, they exert more force beta. Therefore their kinetic energy is more, their force is more, their vapor pressure is also more. So as temperature increases, vapor pressure increases. Okay, hope you are understanding clear. Yes, that's what it is said. As temperature increases, kinetic energy increases and the vapor pressure also increases. So if you consider the vapor pressure curve for some liquids, आपका demonstration का वजह से दे हमें. So vapor pressure here and the temperature. If you take a single graph for any liquid, vapor pressure and the temperature, it is going to increase with vapor pressure increases with the temperature exponentially. ठीक है. So as diethyl ether, ethyl alcohol, benzene, water, octane, if you take, as molecular weight increases, vapor pressure decreases. So this vapor pressure is linked to every colligative property. Okay, so the total solutions and colligative properties is connected to the vapor pressure. So this vapor pressure versus temperature, the curves, various curves we have seen. Okay, in other terms, I just want to say they are related to intermolecular forces, vapor pressure and temperature. I have given liquid A का कर्व है, liquid B का कर्व है, लिक्विड सी का कर्व ऐसा है ना. सो दैट ये गिवन टेम्परेचर में वेपर प्रेशर ए का ज्यादा है, बी का और थोड़ा कम है, सी का और थोड़ा कम है ना, राइट. सो vapor pressure increases with increasing temperature exponentially. Yes, Ravindra Reddy, that is explained on the basis of Clausius-Clapeyron equation. आपका अगले स्लाइड में आएगा. ओके, कमिंग टू जिस लिक्विड में इंटरमॉलिक्यूलर फोर्स ज्यादा है उस लिक्विड का वेपर प्रेशर कम होगा. सो इंटरमॉलिक्यूलर फोर्स, that is maybe van der Waals force, London dispersion force, ion dispersion, whatsoever, or hydrogen bonding. As intermolecular force increases, vapor pressure decreases. जिस लिक्विड का वेपर प्रेशर ज्यादा है उस लिक्विड में इंटरमॉलिक्यूलर फोर्स कम होगा, है ना. दे आर रिवर्स. सो इंटरमॉलिक्यूलर फोर्स A is less than, B is less than C. So, this kind of increasing order, decreasing order, vapor pressure order, intermolecular forces, everything it is asked in the NEET kind of examination, my dear students. So, you are preparing all these things for the sake of writing some examinations, mind it. So, we have to focus on what examination, let it be whatsoever examination, a concept का वजह से लिखना है. So, this is the concept and this is the trick to understand. Hope you are understanding concept. Okay, give thumbs up here in the chat box. Ravinder, okay, Suraj, Rajput, okay, और क्या? Any doubt? Ha. Okay, come on, let us see. Clausius-Clapeyron equation. Clausius-Clapeyron equation. So, effect of temperature and vapor pressure is liquid is given by Clausius-Clapeyron equation. So, this is your Clausius-Clapeyron equation, that is LNP means vapor, P stands here vapor pressure, is equal to minus delta H vap, mean to say enthalpy of evaporation upon R gas constant into 1 by T plus constant. Okay, this is called a Clausius-Clapeyron equation. So, in this Clausius-Clapeyron equation, if you take a graph, here P is the vapor pressure of liquid. Okay. So, I just want to write this LNP is equal to minus delta H vap, okay, that is upon into 1 by T plus constant. Delta H is enthalpy of evaporation of the liquid. हाँ funky, good afternoon, कुछ बोलना चाहता हो? I can't understand. ये पहले दिया क्या? 18 grams of glucose is dissolved 90 grams of water, then the relative lowering of vapor pressure of the solution. Yes, that question, I think it is there in the questionnaire. We will discuss that. Okay. You got a doubt? Definitely I will discuss with that. When I ask that doubt, I ask to present the doubt, you present it, then I am going to answer that. Clear beta? Right. T is an absolute temperature. So, R is a gas constant. You want to take it to natural logarithm to the base 10. So, that is logarithm to the base 10 of the vapor pressure is equal to minus delta H vap by 2.303 R into 1 by T into constant. Okay. So, this is actually you do not have the questions in this particular chapter, rather you have the question this Clausius-Clapeyron equation that you can use in the thermodynamics. So, this is related to thermodynamics. So, when you talk about this particular equation, I just want to say it appears like y is equal to the entire term is m into 1 by T is x plus c. Y is equal to mx plus c. This equation appears the equation of a straight line. So, that on the y axis I just want to take log p, and x axis I just want to take 1 by T. So, you are going to get a straight line. Because this value is negative. So, you are going to get a straight line with a negative slope. Are you getting or not? Clear? Now, you will understand. Again, I want to just explain. This particular equation appears like y is equal to m x plus c. This is an equation of a straight line. This equation of straight line type of things you have in chemical kinetics also. So, based on this graphs you can get a question in NEET examination, my dear students. Okay. Why it is a negative slope beta? Why it is a negative slope? Slope is going to be here log p again and 1 by T slope is equal to minus H VAP upon 2.303 R. Okay. So, it is going to be a straight line with a negative slope, and the slope is going to be tan theta. So, you can calculate mathematically this theta, and you can calculate the slope, and you can calculate enthalpy of evaporation of the solutions. That kind of questions you do not need it for NEET, but for the sake of safety I am telling you, but these graphs are important, this equation is important. Fine. Any doubt? Any doubt? Okay. Right. So, vapor pressure, boiling point, a boiling point, yes, this vapor pressure is linked to the boiling point. What do you call a boiling point? Yes, of course, Ravinder, you said. Pranav Balaji, good afternoon. Good afternoon. Okay, still students has to come. Okay, come on. What is the meaning of a boiling point? What is the meaning of a boiling point? I want to know. Right. Can I get an answer there? Yeah, the temperature at which a substance will start boiling. Pranav Balaji, a nice answer. Saturation temperature with what? Saturation temperature with what? Yes. So, actually what happens when you heat it now, take a liquid, this is a liquid, when you heat it, it become hot, right? It become hot. When you keep on heating, what happen? Keep on heating, ये पानी उबाल देंगे. This is called boiling. Right? Let us observe what is happening here. Here there is atmospheric pressure, right? There is an atmospheric pressure, and there is a vapor pressure. This is a vapor pressure, right? So, atmospheric pressure is coming from the outer side of the liquid, and vapor pressure is actually generated from the liquid. है ना? When these two become equal, na, what happen? There is a fighting between these two, so that the liquid surface, this vapor pressure and atmospheric pressure, there is an equal pressures. So, when this equal pressure a janjat में bubbling आ जाएगा, bubbles will come. So, that temperature is called as boiling point temperature. That is called boiling point temperature, BP. So, BP, boiling point temperature, is the temperature where atmospheric pressure or external pressure is equal to the vapor pressure of the liquid. Got my point? Got my point clear? So if you take a graph, a graph between vapor pressure and temperature, yes, it increases like this. Okay. So in this, as it is reaches to some value like this, okay. If it reaches to 1 atm, okay, so this is the temperature the liquid is going to boil. Okay, this is called boiling point temperature, right? So in the chart box you can all see. So to achieve better scores in the next attempt, you please get the Google form, the link it is given, so that you will be getting complete updates on the NEET 2025. You please click it. Okay. By the way, any doubt here? Now, what happens when you use a pressure cooker? When you use a pressure cooker and you cook it, cooking time is decreased or increased? अरे अगर प्रेशर कुकर में कुक करने तो खाना जल्दी पका सकता है ना, क्यों? There is a discussion about this vapor pressure. It's a great discussion about the vapor pressure. So a person who is somewhere on the sea level, a person who is on the top of the hill, here atmospheric pressure is less than 1, here P atm is equal to 1. So as it is less pressure, when you want to cook something, as the pressure is less, somewhere it is going to boil. So the boiling temperature कम होगा, right? When the boiling temperature कम होगा, मतलब क्या? It boils, but inside the food it will not be cooked, क्योंकि ये temperature बहुत कम है. If you increase the pressure, so boiling point somewhere it is going to be like this. So ज़्यादा गर्मी करना है boil करने के लिए, so that more heat is absorbed, so that the cooking process is going to be more effective. Are you getting or not? That's the reason why those people who are at high altitudes and hill areas, they take some more longer time for cooking. That is a logic that is there in the explained in the physics as well as in chemistry. है कि ना? So कभी सोचा है क्या? Have you ever visited a hill station, my dear children? Okay, right. ठीक है, एक मिनट. हाँ, प्रणव बालाजी, what is your favorite hill station? So what is your favorite hill station? Darjeeling? No? Ravinder, what is your favorite hill station? Himachal, right. Okay, आगे बढ़ेंगे. So the boiling temperature, that's I want to say, the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure is called the boiling point of the liquid. It is indicated with the TB. Evaporation occurs at all temperatures, but boiling occurs only at boiling point. Evaporation can occur at any temperature, but evaporation can be low at room temperature and high at boiling point temperature, right? So here, very important point, the boiling point of a liquid changes with change in external pressure and also by addition of volatile or non-volatile substances. That's what I want to say. You want to cook dal, you simply add water and cook it, it cook nicely. But the dal you want to cook, simply thoda sa namak add karne to, salt. It is a non-volatile solute, na? So that it will not be cooked. Reasons can be many, surface tension के हिसाब से बोल सकते हैं, vapor pressure के हिसाब से बोल सकते हैं, right? Talking about, so the vapor pressure, again the vapor pressure of a liquid solutions. You have to understand the vapor pressure of the liquid solutions. When a liquid and a liquid, two liquids are mixed to form a binary solution, the vapor pressure may increase, the vapor pressure may decrease. That is given by Raoult law. So let's talk about, for a solution of a liquid in liquid, as both the components are solutions of the volatile. Liquid means it's supposed to be a volatile, okay, and each component form vapor above the solution, right? And let us consider a mixture of two completely miscible liquids, A and B, two liquids, and the mole fraction of this is XA and XB. Suppose at certain temperature their partial pressures are said to be PA and PB, and the partial pressures in the pure state is said to be P0A and P0B. Let me give you a diagram and let me explain you that. So this is a liquid A, this liquid A, and this is a liquid B. This liquid A, I just want to use green, it is evaporating and you are having vapors of the A. Got it? These vapors of the A, in the pure state, it is said to be P0A. P0A indicates, carefully you observe, P0A indicates vapor pressure of pure liquid A is B. This is liquid B. When this liquid B is taken separately and this liquid B has the vapor pressure, so that B component is indicated with blue, so that is indicated as P0B. You have two liquids whose vapor pressure is P0A in a pure state, in another vessel P0B in pure state, है ना? Now these two liquids are mixed. These two liquids are mixed, so that you are going to get a mixture. You are going to get a mixture. Carefully you see. ये मिक्सर में क्या क्या चीज है? Liquid A as well as liquid B. Got it? A liquid A liquid B साथ में फिर evaporate होता है. So अगर evaporate होने के बाद हाँ, it is giving the vapors of both A and B, है ना? So this is a mixture. This is a mixture. Vapor pressure of liquid mixture means solution. This is a solution. समझ में रहे क्या बेटा? ओके, नाउ उसमें दी वेपर प्रेशर पूरा के पूरा वेपर में ये जो चीज है, दिस इज पी ए एंड दिस इज पी बी. PA अलग है P0 A से, PB अलग है P0 B से। रविंदर बोलो क्या फर्क पड़ता है दोनों को? ये दोनों का क्या फर्क है बेटा? ये दोनों का क्या फर्क है? जल्दी बोलो। हाँ, वाई यू केप्ट क्वाइट? प्रणव, रविंदर, जल्दी बोलना। ओके, सो प्रणव हिमालय में टक गए क्या? राइट, देखना चाहता हूं। सो P0 A, P0 B और द वेपर प्रेशर्स। सा ये P0 A, ये PA, ये दोनों में क्या फर्क बढ़ता है? आर दे सेम और डिफरेंट? इशिता है नहीं क्या आज? हेलो इशिता, हाय। रविंदर, right, so P0 A, vapor pressure of pure liquid A, P0 B, vapor pressure of pure liquid B। तो PA क्या? So vapor pressure of A in liquid in solution। PB is vapor pressure of B in solution। That is the difference between this and this. Now you got Pranav? Now my discussion is these slides and these diagrams you have to make so that you will understand that itself is a Raoult law, right? Got it? Yes. So let me give you further explanation for this. According to Raoult law, something is given, I'll explain you. This is the mixture na, this is the mixture na. Look at this is the mixture. This mixture I just want to have a discussion here. There are two experiments. You have A and B. This is one experiment. One more experiment I want to give you. What do you understand between these two? Somebody please tell me. Children. Ravinder, hello Ravinder, are you online? Okay, we are about to start your doubt. Right, what do you find the difference in these two diagrams? Yes, some interaction. Here A is more in the liquid, first the green particles are more, yes, in the second blue particles are more. So particle means, you go to the previous slide, a component A, component B. Here जहाँ पर कंपोनेंट लिक्विड में ज़्यादा है, इसका वेपर का जो प्रेशर रहता है ना, दैट प्रेशर भी ज़्यादा होगा, राइट. दैट्स व्हाट आई मीन टू से. पार्शियल वेपर प्रेशर ऑफ ये यहाँ पर ज़्यादा है कम है कैसे बोल सकते हैं, कॉन्सेंट्रेशन टर्म का हिसाब से बोलना है. सो कॉन्सेंट्रेशन टर्म्स के हिसाब से मोल फ्रैक्शन बता सकते हैं ना. पी ए इज डायरेक्टली प्रोपोर्शनल टू मोल फ्रैक्शन ऑफ ए, राइट. यहाँ पर आई कैन से right, Pb is directly proportional to mole fraction of B. So ये liquid mixture में mole fraction of A and mole fraction of B होगा, mole fraction of A, mole fraction of B होगा, right. So it is given with Pa is equal to P naught A mole fraction of A. Similarly, Pb is equal to P naught B mole fraction of B. This is what is called as Raoult law. Raoult law says this is what is partial vapor pressure is directly proportional to the mole fraction. So I just want to write the definition का हम मिस किया. The partial pressure, the partial vapor pressure of a component is directly proportional to its mole fraction. That is what is said to be Raoult's law. Any doubt? Raoult law is very, very important in CBSE as well as the NEET examination. So आप लोग my dear students, so NEET examination you are doing a lot of hard work, we are also doing a lot of hard work, so that let this hard work shouldn't go waste. That's the reason why my dear students, you please like these sessions and share the sessions and subscribe to the channels. पिंकी और कुछ बोलना, सब मेरे को समझ नहीं आ रहा है कि टॉपिक की वजह से कुछ बोलना चाहता हो तो बोलो. पिंकी जा. हाँ. So I want to say, according to Dalton's law, total pressure is equal to P1 plus P2, right? So total vapor pressure of the solution, mean to say this is the total vapor pressure of the solution, is equal to Pa plus Pb. Pa is equal to P naught A mole fraction of A. Pb is equal to P naught B mole fraction of B. This is how you just use the Raoult law. समझ में आ रहा है क्या बेटा? जल्दी. So we can go with some questions based on this. रविंदर कहाँ गए तू? Hello रविंदर. You can also say P total is equal to mole fraction of A, mole fraction of B sum करके 1 होना है ना. So mole fraction of A mole fraction of A plus mole fraction of B is equal to 1. So that mole fraction of B is equal to 1 minus mole fraction of A you can write, or mole fraction of A you can write as 1 minus mole fraction of B. So that you can say mole fraction of A, P is equal to P naught A of 1 minus mole fraction of B plus P naught B mole fraction of B. These are the equations that is typed and maintained here. So ये P naught A P naught B कॉमन निकाल के मोल फ्रैक्शन ऑफ B प्लस P naught A लिखना है. So this is also useful expression. P total means total pressure of the solution. समझो बेटा? Any doubt? Okay, Pinky? Chalo. Right. Now let's go. What is an ideal solution? What is a non-ideal solution? जो solution Raoult law follow करता है हर condition में, that is what you call it as a ideal solution. Okay, so this is the graph we just want to discuss here. So let us talk about P1 and P2 or PA and PB. This is a vapor pressure and this is a mole fraction. So mole fraction of A and mole fraction of B. Mole fraction of A 1 to 0. So as mole fraction of B 0 to 1. So as mole fraction of B increases, its vapor pressure increases, that is P2. Right? As mole fraction of A increases, its vapor pressure also increases. Right? So that the sum of these two is going to be P total is equal to P naught A mole fraction of A plus P naught B mole fraction of B. In this scenario, it follows the equation of a straight line. जो solution ये graph follow करता है ना, that is called ideal solution. So what are ideal solutions? So ideal and non-ideal solutions. Right. So ideal and non-ideal solutions. Ideal solutions, an ideal solution is a solution which each component obeys Raoult's law under all conditions of temperatures and concentrations. So it should accept all solution laws, Raoult law and this graph. Right. An ideal solution will satisfy the following condition. ये conditions काफ़ी important है. So there will be no change in the volume. I just want to say here I just want to add one point here. Intermolecular forces before mixing, when A and B are mixed, should equal to after mixing. So before mixing should equal to after mixing. I want to say when A and B are mixed. So before mixing there should be interaction between A and B and B. Molecule between A and A there is an attraction, and B and B there is an attraction. When you mix now, the magnitude between A and A should equal to A and B and B should equal to A and B. So this is the prime condition, then only the other conditions are going to be satisfied. Clear? So there will be no change in the volume on mixing two components. Therefore delta V mix is going to be 0. What is this meaning? If you mix 10.0 milliliter of A, 10.0 milliliter of B, when these two are mixed, you are going to get 20.00 milliliters of a solution. There shouldn't be any change, and there will be no change in enthalpy. So, there is no change in the heat. So, when you dissolve, there is no bond breaking, there is no bond formation. Such solutions are going to obey that kind of graph. So, one more example, when this mix 50 milliliter, centimeter cube means milliliter, 50 cm cube of benzene with 50 cm cube of toluene, the volume of the solution is found to be exactly 100 centimeter cube. That is what you call it as enthalpy of mixing is going to be 0, right? And hence the solution is at is ideal. Ideal solution actually doesn't exist. Somewhere we have to consider it exist, right? A few examples of solutions are given below here. Benzene and toluene, N-hexane and N-heptane, ethyl bromide and ethyl chloride, chlorobenzene and bromobenzene. So, do we have to memorize these questions? That is my question. Do we have to memorize these examples, my dear children? Any interaction? Do we have to memorize these? Yes, of course no. Of course no. So then तब आपको कैसे पता चला कि एग्जाम्पल में ये चल रहे हैं? हाँ, बेंजीन का स्ट्रक्चर देखो, आपका जो इंटरमॉलिक्यूलर फोर्स है ना, this is your benzene, this is your toluene, this is your toluene. ये benzene toluene molecular structure is same and molecular mass भी बराबर है दोनों का, and the nature of intermolecular force is same. Then only it is going to form an ideal solution. That is the trick. So, trick. Find intermolecular force. Grade 11 states of matter, first page, NCERT book, you have intermolecular force. Remember? If you read that, you will understand what kind of intermolecular forces are there. Van der Waals forces, N-hexane, N-heptane, alkane, alkane, Van der Waals force, London dispersion force, ethyl bromide and ethyl chloride, what kind of force it is? Ethyl bromide, you have ion dipole force. Ethyl chloride, you have dipole force. So, forces are same. Chlorobenzene, bromobenzene, dipole force and dipole force, सब चीज में London dispersion forces होता है. Okay, बेटा, this is about the few examples, and I have given a trick to understand intermolecular forces and finding ideal solutions or non-ideal solutions, right? So, any solution which follows that graph that we discussed is going to be an ideal solution. Any doubt? Please, अरे कम से कम like मारो यार. Students, are you there online? Hit like button, जल्दी. हाँ, it's hot, is weather hot. Okay, hello, can you able to hear me? Can you able to hear me? Definitely Pranav Balaji. Arey, I'll just draw the diagram also. Can you able to hear me? Just give me a response. Yes, that's good, that's good. So, I just want to say here, when two components are mixed, okay, we know that vapor pressure and mole fraction, okay, vapor pressure is directly proportional to mole fraction, है ना, right? So that, yes, it is going to be like this. mole fraction, hit like button. Guys, mole fraction 0 से कहाँ तक होगा? 0 से 1 होगा, right? The same graph I just want to draw like this also. I can draw like this also. Got it? So that vapor pressure and mole fraction, it can also be like this. You want to draw it for PA and mole fraction of A, PB mole fraction of P. I just want to draw these two graphs on the same graph paper. It is like this, so that it is coming PA and a mole fraction of A, right? And you can have PB mole fraction of B. So, as PA increases, as mole fraction of A increases, got it? And PB increases as mole fraction of B increases. Now we understand? Neha Gupta, we are here to learn and raise. So, जो भी हुआ, okay, past is past, we are not in a position to discuss, right? So, even being a teacher, I trained thousands of people every year. I don't bother about that, because सच में be genuine things can happen. अच्छा सोचो, अच्छा होगा, बस यही मंत्र है बेटा. जो भी चीज़ है, पढ़ना, ओके, पढ़ाई करो, काम करो, नौकरी करो, खेलो, अच्छा खेलो, अच्छा होगा, अच्छा करो, अच्छा होगा, अच्छा सोचो, अच्छा होगा बेटा. Neha Gupta. So, this is a YouTube channel where we are learning many things. This platform is not intended to discuss about the controversial aspects. हाँ, सब मेरे को लग रहा है, लेकिन I don't want to discuss it. This is not the way. Okay, thank you beta, thank you. Now, this yellow line indicates, Pranav, for you I am just designing this again, PA. This is about PB. When these two are joined together, that is going to be PS. PA plus PB. So, any solution obeys this graph is said to be an ideal solution. Clear children? Clear? Don't say sorry Neha, don't say. Okay, some burning sensation will be there. आप लोग इतना मेहनत करके कुछ किया, okay, कुछ आवाज सुन रहे हैं कहीं से, so don't listen that. Okay, then you are going to be your mind is going to be such a tranquil state, है ना बेटा? Otherwise your mind is going to be in a turbulent state. Don't say sorry, because I feel my classroom is always right, just like my own family. I don't say sorry to you, you please don't say sorry to me, है ना? Right. Come on. Talking about, कुछ डाउट है क्या नेहा उसमें? Yes. That's good. Vapor pressure, अरे भाई नॉन आइडियल सॉल्यूशन है. ये नॉन आइडियल सॉल्यूशन है क्या? नॉन आइडियल सॉल्यूशन, those solutions which do not obey Raoult law at all conditions, it is called non ideal solution. उसमें जो भी इक्वल बना दिया पहले स्लाइड्स में, अब भी नॉन इक्वल होगा. अब भी नॉन इक्वल होगा तो ये ग्रेटर हो सकते हैं, ये लेसर हो सकते हैं, है ना। सो अगर ये ग्रेटर होगा तो पॉजिटिव डिविएशन है। हाँ यस प्रणव बालाजी यू सेड करेक्ट। अरे एंड लेस देन होना तो नेगेटिव से, नेगेटिव है ना तो लेस देन है तो नेगेटिव डिविएशन है। So when you mix many things, I just want to give you non-ideal solution deviation. Just I'll draw my own graph. I'll draw my own graph. For non-ideal solution, let me tell you example with a proper for non-ideal solution positive deviation. A positive deviation है क्या? इंटरमॉलिकुलर फोर्सेस ये एंड ये बीच में, बी एंड बी बीच में, एंड ये एंड बी बीच में. What is this? Before mixing and after mixing. So after mixing, the intermolecular forces, Death Star, hi, what a name here. Okay, so when A and B are mixed, the intermolecular forces A B का बीच में कम होगा. Okay, so intermolecular forces कम होगा, right? So intermolecular forces कम होगा का मतलब क्या? Vapor pressure ज़्यादा होगा. Are you getting or not? Fine. Vapor pressure ज़्यादा होगा. हमारा असली वेपर प्रेशर का कर्व कैसे देखना? That is PA, mole fraction of A, PB, mole fraction of PA. If it is a straight line, है ना? It is supposed to be like this. If the ideal solution is like this, ideal solution, a ideal solution का hypothetical. Now you just see if वेपर प्रेशर ज़्यादा हो रहा है, वेपर प्रेशर ज़्यादा हो रहा है, सो वेपर प्रेशर सपोज टू बी ए स्ट्रेट लाइन हियर, लेकिन वेपर प्रेशर ज़्यादा हो रहा है. दैट इज द एक्चुअल ग्राफ, राइट? वेपर प्रेशर ज़्यादा हो रहा है, वेपर प्रेशर ज़्यादा हो रहा है, इससे ज़्यादा हो रहा है. अंडरस्टैंड? सो दिस इज व्हाट यू कॉल इट एज PA, PB, PS is equal to PA plus PB. Are you getting or not? Clear children? Fine. So when intermolecular force कमी आ रहे हैं, क्यों कमी आ रहे हैं? क्यों कमी आ रहे हैं? I want to give you an example. Water plus ethanol. Water plus ethanol. If we talk about the water, oxygen, hydrogen, 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 oxygen, hydrogen, दोनों के बीच में आपका इंटरमॉलिकुलर हाइड्रोजन बॉन्डिंग होगा. ओके, नाउ इफ C2H5OH ऐड करने तो C2H5OH, C2H5OH, so this is hydrophobic group. This hydrophobic group ये बीच में घुसा के हाइड्रोजन बॉन्डिंग डिसरप्ट कर रहे हैं. अंडरस्टैंड? एज हाइड्रोजन बॉन्डिंग बिटवीन वाटर एंड वाटर इज डिसरप्टेड, सो जो सॉल्यूशन ये वाटर एंड इथाइल अल्कोहल बीच में फॉर्म किया उसमें इंटरमॉलिकुलर फोर्सेस कम होगा. लाइक दैट यू नीड टू स्टडी. Whenever the molecules are separated, water molecules are separated, the molecule बीच में डिस्टेंस बढ़ रहा है. इसी का कारण वॉल्यूम मिक्स इज ग्रेटर देन 0. अंडरस्टैंड. नाउ पुराना का जो हाइड्रोजन बॉन्ड है ये ब्रेकिंग के वजह से एनर्जी इज रिलीज्ड. सो डेल्टा H mix is greater than 0, right? Exothermic process, right? Now intermolecular forces is the key point. Now this is the entire thing I just want to give you as a graph. This is the one. So this is for a non-ideal solution showing positive deviation. Pi is greater than mole fraction of A, P naught A, and Pb is greater than P naught A, B mole fraction of B, P total is greater than that. Delta H mixing is positive, delta V mixing is positive. Okay, I just want to say intermolecular forces A, B and B and A and B. So this is the key point. If you keep this mind in your database, you can understand many things. Okay, example acetone and carbon disulfide. Okay, acetone and ethyl alcohol, acetone and benzene, and methyl alcohol and water, or ethyl alcohol in water. Ethanol plus water. Okay? So like that you need to understand the positive deviation, right beta? Now let us talk about the negative deviation. अभी तो फिलहाल positive deviation देखा, now negative deviation देखना जरूर है. So let's go ahead. Ethyl alcohol and water पे दिया, carbon tetrachloride chloroform, carbon tetrachloride benzene, carbon tetrachloride and toluene, right? So non-ideal solution showing negative deviation. अरे here a negative deviation का okay. So I just want to give you a negative deviation का. ये negative deviation में ये क्या हो रहा है, ये B A and B. So A and B बीच में intermolecular force ज़्यादा है. So A and B when it is mixed, इसमें intermolecular force बढ़ रहे हैं. How it is? So let us talk about example. Chloroform plus acetone, chloroform plus acetone. What is chloroform? Chloroform का फॉर्मूला बता दो. प्रणव बालाजी, प्रणव, नेहा, come on, chloroform का फॉर्मूला बता दो. Chloroform acetone CH3 CH3, right? Chloroform CHCl3, right? Acetone, this is acetone, and this is chloroform. If you take a pure chloroform, बिना इसमें क्लोरोफॉर्म में हाइड्रोजन बॉन्डिंग है नहीं, एस्टोन में हाइड्रोजन बॉन्डिंग है नहीं. ओके, लेकिन तब जब आप मिक्स करते हैं ना, ये दोनों का बीच में हाइड्रोजन बॉन्ड शुरू होगा. हाइड्रोजन बॉन्ड शुरू होगा. इंटरमॉलिक्यूलर फोर्स बढ़ गया. अगर इंटरमॉलिक्यूलर फोर्स बढ़ गया तो मतलब वेपर प्रेशर कम आ रहा है. वेपर प्रेशर कम आ रहा है. अंडरस्टैंड? क्लियर? So that if you draw a diagram, vapor pressure of A, vapor pressure of B, mole fraction of A, mole fraction of B. So, as mole fraction of A increases, vapor pressure should increase if the solution is ideal, right. For here also, for a solution, it is supposed to be like this. It is supposed to be a straight line. It is supposed to be a straight line. Understand? So, as vapor pressure decreases, as its vapor pressure decreases, it comes like this. It comes like this. It comes like this. Are you getting or not? This is what do you call it as? Pranav you said is correct. So, P A ka, a P B ka, and P S ka. Got it? So, the vapor pressure gradually decreases. When intermolecular force increases, molecule and molecule come closer, na? Therefore, what happens? Delta V mix is less than 0, delta H mix is less than 0. That is what is explained in terms of negative deviation from Raoult's law. Clear? Yes, beta. Now, that's what it is shown in this graph. So, I just want to give my own graph, handwritten graph. Okay. Any doubt? Any doubt here, children? Any doubt? Now, let us see the same scenario here. Thus, for a non-ideal solution, these are the main things. Pa is less than P naught A mole fraction of A, Pb is less than P naught B mole fraction of B, P total is less than sum of the Pa and Pb. Enthalpy of mixing is negative, enthalpy change in the mixing, and delta V mixing is negative, right. A few more examples: chloroform and benzene, chloroform diethyl ether, acetone and aniline, and HCl and water. You see the examples. You just analyze each example and understand how you understand Raoult law very well. Okay? Now, HCl and water, HNO3 and water, acetic acid and pyridine. Okay, what is pyridine? Pyridine. This is your pyridine. Okay? Now talking about azeotropic mixture. Azeotropic mixtures are the mixtures which boil together. So, at certain composition, they are called azeotropic mixture. Azeotropic mixture are non-ideal solutions, definitely supposed to be non-ideal solutions. We discussed ideal solution, non-ideal solution. They have same composition in liquid phase as well as vapor phase. Therefore, if you want to boil, they boil together, so you can't separate by fractional distillation or any kind of distillation. Okay. So, they have the same composition in the liquid phase and in the vapor phase. So, there are two types: minimum boiling azeotrope and maximum boiling azeotrope. If you go into the azeotropic mixtures, it is a huge subject, but I want to give you a simple trick, my dear students. Minimum boiling azeotropic mixture is जो mixture which follows positive deviation from Raoult law. Whereas maximum boiling azeotropic means these mixture of solutions, non-ideal solutions, which show negative deviation from Raoult law. So, that is very, very important. So, in the exam you will be asked a NEET exam, you will be asked a question about which of the following show maximum boiling azeotrope, which of the following show minimum boiling azeotrope. The simple trick is the mixture which shows positive deviation, उसमें positive आ रहा है ना, इसके opposite पकड़ो. So that is a minimum boiling azeotrope. The mixture with the negative deviation from Raoult's law, it is going to show the reverse way. Are you getting or not? So in today's class, I just want to conclude today's class because I have a class immediately. So today we discussed about the vapor pressure, conditions for the vapor pressure, how vapor pressure and its factors, and the relation between vapor pressure and the boiling point we discussed, and we discussed about the vapor pressure curves, Raoult law, and ideal solution, non-ideal solution, इसका graph है, and azeotropic mixtures भी हैं. So कल का class, tomorrow Saturday will be concluding these solutions on colligative properties. We will be doing some numericals based on this also. Ravindra Reddy, get ready for your doubts and all, okay, and get ready with your doubts, my dear students. And colligative properties and Van 't Hoff factor, the entire solutions colligative properties is connected to the Van 't Hoff factor, right? So we will discuss more into that. Okay, so children, see you for the day. So I request you to like this session and share and subscribe. Okay, thank you very much. Stay tuned tomorrow's class. Bye bye.